Hello, my name is I'm a PhD in epidemiology who has recently graduated from the Faculty of Veterinary Medicine, University of Tehran, Iran. And in this video, I'm going to discuss and introduce joint point regression analysis. Joint point regression analysis, also known as segmented regression, multi-phase regression, piecewise regression, and change point regression, is a linear regression which is composed of a few continuous linear phases, where joint points are specific points where the values of the dependent variable may exhibit a change from the previously established pattern. In this example, as you can see, the data starts with an increasing trend and there is a change in the average, and it's followed by a decreasing trend, which has been described by three linear lines and two join points between these lines. The general model for joint point regression is the average of the dependent variable over time equaling the intercept plus the first join point and the rest of the join points. However, in joint point trend analysis software, the model is the same, but logarithmic transformation is also applied. In each segment of joint point regression, there are two parameters, trend and level. Level is the value of the series at the beginning of the given in time interval of that segment. And the trend is the slope, which is the rate of change of the measure in that segment. In joint point regression software, there are a few definitions that are important, including annual percent change, which is equal to 100 multiplied by exponential of beta minus 1. In joint point regression analysis, we are using linear regression. Therefore, the rates are assumed to change at a constant percent of the rate of the previous year. Average annual percent change, or AAPC, is a summary measure of the trend over a pre-specified fixed interval. So unlike APC, which is automatically computed, we can specify AAPC for different time points. For instance, we can ask the software to calculate the AAPC for the last 5 years or last 3 years or the entire range of the time series. It is computed as a weighted average of the APCs from the joint point model, with the weights equal to the length of the APC interval. However, if AAPC is calculated in a series that is also within one joint point, the AAPC will equal APC. In joint point regression, we use model selection methods to determine the number of joint points. In joint point trend analysis software, the available model selection methods are permutation test, which is the best, weighted Bayesian information criterion, which takes less time to be computed, data-dependent selection, Bayesian information criterion 3, Bayesian information criterion, and modified Bayesian information criterion. Grid search is the method that we use to estimate the location of the join points and to fit trend data within the segment, within each segment. The grid search method evaluates the grid of all possible join points based on the locations defined using the specified constraints in the software which we choose. Joinpoint regression in health research has been used for the determination of the trends of health outcomes over time, to make predictions, and to determine the effects of the interventions, including short-term and long-term intervention effects. For instance, in quasi-experimental study designs where a policy was implemented and we want to determine if the policy changed the average of that health outcome. In this slide, you can see three examples of the use of Joinpoint regression for the determination of health outcomes over time and for prediction. In this slide, you can see the studies where Joinpoint regression was used for the determination of the effects of the interventions. And in this slide, you can see the references that I have used for this presentation. Please like and subscribe if you would like me to make more videos about joint-point regression. In future videos, I will dive deeper into joint-point regression analysis and explain each step with more detail. Thank you so much for watching this video.